Hello, my dear students, and the rest of the learners. Welcome to part 3 of 8 in the series of computer unit by the title Fundamentals of Developing Computer Program, with our focus in this presentation being on program development. My name is Mema JM, or you can simply call me Emily Swap. In this presentation, we are going to look at the introduction, program development, the program development methodologies, the phases of program development. Let's begin by looking at the introduction. When we speak about program development, we are simply saying that program development is an ongoing systematic process that programmers follow as they try to come up with sets of instructions that can be executed by a computer to solve some of the complex problems that human beings would either take too long to solve manually, or they would not be able to solve at all. Usually, a problem is any task that requires a solution, and it can be simple or complex. This process involves a series of steps that must be followed systematically if a programmer has to develop a valuable and worthwhile program. In order for a programmer to come up with a solution to a problem, he or she must do the following, or what we call the process of creating programs. Number one, he or she must have a clear understanding of the problem. Number two, should be able to determine what we need, or what he or she needs to help solve the problem. Number three, he or she has to decide what results he or she wants to achieve. Number four, the programmer must consider different ways to achieve your ace or results and select the best one. Number five, one must come up with a step-by-step sequence of instructions to be followed to achieve a solution to the problem, or what we call an algorithm. Therefore, during the process of developing the program, one should ensure that the correct requirements are identified at each stage before the next stage is initiated. In addition, one is required to document whatever that he or she does at every stage of the program development lifecycle. This is important so that the facts are recorded when they are still fresh and in the required detail by the programmer. Therefore, before a programmer commences the activity of coding a program, he or she has to make sure that he or she has carried out the analysis of the problem, has planned on how the problem will be developed or how the program will be developed, and has put in place controls for the development process. This approach is called a programming methodology. The basic purpose of these methodologies is to provide smooth software development according to the project requirements. So, what are program development methodologies or software methodology? A software methodology is a structural approach to developing and maintaining software projects. It includes a certain framework of guidelines, techniques, and the processes that allow the team to ensure both the quality and efficiency of their work. Software methodologies also enable work consistency, helping the development team to see the milestones of their work and general direction. The following are therefore some program development approaches or methodologies that a programmer may embrace during program development, or what we call system development methodologies. Number one is the Agile. Number two, Crystal. Number three, Rapid Application Development or RAD. Number four is Waterfall. Number five is Scrum. Number six is Spiral. Number seven is Gantt. So what is Agile methodology? This is a practice that promotes continuous iteration of development and testing throughout the software development lifecycle of the project. In the Agile model, both development and testing activities are concurrent unlike in the waterfall model. It is an approach to software development under which requirements and solutions evolve through the collaborative effort of self-organizing and the cross-functional teams and their customer or end user. It's an iterative approach that prioritizes collaboration, flexibility, and efficiency. The Agile breaks projects into small increments, typically lasting 2 to 4 weeks, and focuses on delivering working products after each sprint. The Agile development is used to minimize risks by developing software in a short time boxes, which are called iterations, that generally last for 1 week to 1 month. Number 2 is Scrum methodology. Scrum methodology is a project management methodology that's a subset of Agile. The Scrum organizes work into sprints, and each sprint is intended to deliver a potentially shippable product. The Scrum software development model begins with a brief planning, meeting, and it concludes with a final review. The businesses can accelerate the development of software using this method that allows a series of iterations in a single go. It is one of the best software development methodologies because it easily brings slowest progressing projects on track. Use Scrum development for fast-moving, cutting-edge developments, rapid cons, and testing mistakes that can be easily rectified. In this methodology, decision-making is entirely in the hands of the teams. Number 3 is what we call the Christo method. Christo family is a collection of Agile software development methodologies that can be used for different software projects depending upon size, complexity, criticality, and the number of people involved. It involves frequent communication among team members in order to improve the software success rate. It therefore focuses on the people and the communication among people during program development rather than a process to frequently deliver working software. Number 4 is RAD. RAD stands for Rapid Application Development. It is based on prototyping and iterative development with no specific planning being involved. It focuses on gathering user requirements through workshops or focus groups and the testing of the prototypes by the user using the iterative concept, the reuse of the existing prototypes or components, continuous integration, and rapid delivery. It's a condensed development process that focuses on collaboration, fast turnaround times, and a user-centered approach. RAD is most effective for projects with a well-defined business objective and a clearly defined user group. The main objective of rapid application development methodology is to accelerate the entire software development process. The goal is easily achievable because it allows active user participation in the development process. Number 5 is waterfall model. It entails breaking down of a program activities into linear sequential phases where each phase depends on the deliverables of the previous one and it corresponds to a specialization of tasks. This model clarifies the software development process in a linear sequential flow. In any phase of the development cycle, you should always cross-check that the earlier phase is completed. Number 6 is what we call the spiral model. This model focuses on the early identification and reduction of project risks. Each phase in spiral model begins with a design goal and ends with the client reviewing the progress. In the software development methodology, developers start on a small scale, then explores the risks involved in the project, makes a plan to handle the risks, and finally decides whether to take the next step of the project to do the next iteration of the spiral. The success of any spiral lifecycle model depends on the reliability, the attentiveness, and knowledgeable management of the project. Joint application development, JAD, is a requirements definition and user interface development methodology in which end users, clients, and developers attend intense off-site meetings to work out and finalize software systems. This methodology aims to involve the client in the design and development of an application. The JAD sessions easily accomplish targeted goals with a series of collaborative workshops. The main focus of this model is to resolve the business problem rather than the technical details. Let's now look at the criteria for choosing appropriate system development methodology. When choosing a system development methodology, you can consider factors such as the project size and complexity. This is because larger, more complex projects may benefit from structured approaches like waterfall, while smaller projects may be better suited to agile methodologies. Number two is time to market. Some methodologies help reduce the time to market for projects. Number three is budget. Agile can be more cost-effective during its adaptability, but waterfall predictability can simplify budget management. You also need to look or consider the project requirements. Here, you determine if the project has clear defined requirements at the project's start and assesses the likelihood of changes later in the process. Team expertise or expertise. You need to discover what methodologies the development team is well versed in. Number five is communication. Choose a suitable balance between direct communication within the team and documentation-based collaboration. Number six is customer involvement. Consider the level of customer involvement and the feedback required throughout the development process. Number seven is collaborative type. Different collaborative models, such as fixed price, dedicated team, and time and materials have certain characteristics that align with specific methodologies. So what are the phases of program development? The phases of program development form what is called the Program Development Life Cycle, or PDLC, because you can move from the last phase to the first phase. Therefore, a PDLC is a set of steps or phases that are used to develop a program in any programming language. Developing a computer program is not a one-time action, but a process that involves a set of stages or phases which forms a program development life cycle. Therefore, in order to develop a program that can adequately solve the problem at hand, a programmer has to, number one, specify the problem requirements. Number two, analyze the problem. Number three is design the algorithm to solve the problem. Number four is to implement the algorithm. Number five is to test and verify the completed program. Number six is to maintain and update the program. Therefore, the program development life cycle contains the following phases. Number one is problem recognition. Number two is problem definition. Number three is program design. Number four is program coding. Number five is program testing and debugging. Number six is program implementation and maintenance. Number seven is program documentation. The phases can be diagrammatically presented as follows. As you can see, my dear students and the rest of the learners, we organize each of those phases, as you can see, and each phase is linked to the next phase. However, documentation is supposed to be done continuously from stage one of phase one or the end, because as the programming is continuing, as programming is continuous, or is continuing, the programmer needs to keep a record of every activity that is carried out throughout each of the phases. And that's why program documentation has been linked to all the other phases, and it's at the center. Therefore, a program development life cycle is a recommended series of steps that are supposed to be followed when developing a program. Therefore, before committing oneself into writing a program, the following are the steps that must be followed and they form a program development life cycle. Number one is problem recognition. It is also called problem identification. It is the identification of an undesirable situation that needs to be solved, an opportunity that needs to be grasped, or a directive that needs to be implemented by writing a computer program that can address the matter. Example of a problem recognized is the inability by learners to know when to compute either the area or a perimeter of a circle and how to do it. A problem is an undesirable situation that prevents an individual or organization from achieving its purpose and thus needs a solution. To understand a problem, one has to look for keywords such as compute, evaluate, compare, amongst others. Number two, or second phase, is problem definition. It is also called program specification, program analysis, or requirements specification. It is the process of identifying exactly what the problem is and gaining insight through understanding about its exact requirements and sequence of activities to be carried out to solve the problem at hand, such as formulating program objectives, establishing the desired output, identifying the input data required, coming up with the expected processing requirements, and identifying any additional requirement or constraint for the solution. Therefore, during this process, the analyst has to identify the data to be used, the amount of memory to be required, the expected inputs from the user, the devices that will be required, the operations to be carried out, and the expected outputs from the program. In addition, the analyst has to establish the boundaries of the expected program, and if several methods to solve the same problem are identified, the best alternative should be chosen. At the end of this stage, one writes the requirements report or documents for the new program that enables a programmer to come up with a program design that meets the needs or that meets the needs at hand. During problem definition, the programmer has to perform the following 5 tasks. Number 1 is specify program objectives. Number 2 is specify the desired output. Number 3 is to determine the required input and its source. Number 4 is to define processing requirements and the algorithm. Number 5 is to develop program specification document. Therefore, program specification involves the following steps. Number 1 is definition or defining the program by establishing what the program is going to do. Number 2 is to decide on the input, data format, and the structure to be used, as well as the method of data entry, depending on the program requirements. Number 3 is to make a decision on how the processing will take place and what will be required. Number 4 is to specify the output format. The main benefits of program specification include it provides an opportunity for the analyst to rethink the system design at a detailed low level. It also provides a vehicle for communicating with the programmer. It provides a permanent record which describes or documents the activities performed by each program in the system. Number 4, it serves as a guide for program testing after completion. Number 5, it provides a guide to the programmers. So what is program design? Program design is the process of developing the program's processing or solving logic or algorithm to enable the programmer come up with modules of the expected program, showing the flow of events and data throughout the entire program, from the time the data is input to the program, to the time the program gives out the expected information. Therefore, Program design involves developing the method of solving the problem by planning and creating a solution using program design or the program development tools such as the pseudocode, the flowcharts, the data flow diagrams, the structure charts, decision tables, decision trees, among others. Let's now look at program coding. For the next step, step number 4 or phase number 4 is called program coding. This is the actual process of converting the algorithm into a set of instructions or source code using a particular programming language that can be translated into machine readable form, thus enabling the computer to execute the code and solve the intended problem. Some of such programming languages are C, Java, C++, amongst others. At this point, the programmer transforms the design into actual program by developing a source code for it. Each algorithm step is converted into one or more statements in a programming language. Therefore, it involves typing the instructions into a program editor window in the computer in order to tell it how to solve the problem. The programmers use the program specification and decide to write the code necessary to fulfill all the requirements of the program. A good programmer will consider the following. Number 1 is the future maintenance. Does the program or will the program allow for future changes? Number 2 is called readability. You need to include comments within your code in order to enable programmers to identify areas of code quickly and easily. Number 3 is debugging. You need to provide special programming tools to enable the user or programmer to be able to deal with any errors that may arise during use. During this process, it is important that the programmer ensure that the program is readable. Therefore, for effective coding, the following are some guidelines that the programmer can apply in order to make the program readable. Number 1 is ensuring that he or she makes use of meaningful data names. Number 2 is integrating comments in the code. Number 3 is to make use of indentation, that is, arranging lines of code in a program in such a way that one can easily reflect or see the logic structure of the code. Number 4 is writing program using a straightforward code, which people can readily understand. Number 5 is modularizing the program. This is splitting up a program to make it easier to understand. Number 6 is avoiding jumps in the program to transfer control. During coding, the programmer has to make use of appropriate data types, data structures, and the program elements. A data type is the nature of value to be taken by a computer location and defines the operations that can be done on the data, the meaning of the data, and the way values of that type can be stored. The main classifications of data types are simple or primitive data types. These are the data types that are provided by the programming language with built-in support and are directly manipulated by the commands of the programming language. They include Boolean, string, and numeric types such as integers and floats. The Boolean data type represents the values true and or false. String and text types. These hold or store sequences of characters from a character set. The integer data types are data types that hold or present positive or negative numbers without decimal points. The floating point or real data types represent or hold values that have decimal points. The other type or category of data types is structured data types. They are also called data structures or composite types. These are the data types that are created by the programmer by grouping the simple data types together to form new data types that can be operated on using a specific operation. They include array, also called vector, list, or sequence. It stores a number of elements, but of the same type. Number two is the record, also called tuple, the struct or class. This is a data type that is composed of both a mixture of real and integer types. The elements of records are usually called fields or members. Number three is union. These are data types in which definition is done to contain only one type of primitive data type. In other words, in union data type is defined, or union is defined to contain only one or more primitive data types. I repeat, in union, we don't have many data types. Union makes use of only one type of primitive data type. The other type is set. Set is an abstract data structure that can store certain values without any particular order and no repeated values. We also have what we call the linked list. This is linear collection of data elements of any type, called nodes, where each node has itself a value and points to the next node in the linked list. We also have pointers. Pointers are data types whose value refers directly to another value stored elsewhere in the computer memory using its address. The program statements are those instructions that are written by the programmer in order to form or in form of source code to be executed by the translator to do whatever the user wants. These statements are usually of three main types. The first one is input statements. The input statements are used to read or accept data that is entered by the user from the keyboard or from a file and store that value in the allocated memory space. Number two is what we call the output statements. These are used to display information or data on the screen before the computer's memory or write it to an output file. Number three is processing statements. These are statements used to manipulate the input data by performing some arithmetic or logic operations. The program statements are those instructions that are written by the programmer in form of a source code to be executed by the translator to do whatever the user wants. These statements are usually of three main types. I have talked of the input statements, the output statements, and the processing statements. Let's now look at what we call program testing and debugging. That's the fifth stage. Here, program testing is the process of finding out whether the program coded is working correctly and verifying it to see or to ensure that it works as required. Therefore, after the code is developed, it is tested against the requirements to make sure that the product is actually solving the needs as addressed and gathered during the requirements phase. On the other hand, program debugging is the process of rectifying errors or bugs that have been detected during testing and the compilation of a program. Debugging is therefore also known as program validation, or errors in a program are referred to as bugs. Therefore, a bug is an error in a program that may interfere with its operation. Number 6, or step 6 of phase 6, is program implementation and maintenance. What is program implementation? Program implementation is the actual delivery and installation of the new program ready for use and training the users for the system designed. A common practice is to run the new system in parallel with the old system to ensure that if something goes wrong, the business does not come to a grinding halt. But 2, or program maintenance, is the process of making any corrections or updates of the program as need arises. It entails adjustment and enhancement of requirements or correction of errors after the program has been implemented. Stage number 7 of phase 7 is program documentation. Program documentation is the process of writing support materials, explaining how each and every part of the program can be used by users, installed by operators, or modified by programmers. It allows what a program does, or it shows what a program does and the conditions under which it can work. The two main methods of writing program documentation are internal documentation and external documentation. What is internal documentation? Internal documentation is about making the source code readable and understandable in order to help other programmers understand the code statements. On the other hand, external documentation is preparing reference materials such as user manuals and tutorials printed either as booklets or recorded in storage mediums in soft copy. The two main methods of writing program documentation are the internal documentation and the external documentation. Internal documentation is about making the source code readable and understandable in order to help other programmers understand the code statements. While external documentation is preparing reference materials such as user manuals and tutorials printed either as booklets or recorded in storage mediums in soft copy. And with that, my dear students and the rest of the learners, we have come to the end of part 3 of the series. You can proceed to part 4 of the series, in which we are going to learn about program design and analysis. Thank you very much for listening to part 3. Let's meet again in part 4 of this series. Congratulations for learning part 3 of 8 on computer program development in Fundamentals of Developing Computer Program. You can access the rest of the parts in the series, as well as other computer or ICT videos, by clicking or tapping on the Medswap ICT YouTube channel below this video. To subscribe to the channel, tap on subscribe button below this video in YouTube if it's not currently reading as subscribed. For any further correspondence, kindly write it to us through the email medswap@gmail.com. Thank you very much for listening to me. Let's meet in part 4 of the series, and God bless.